So many of us are caught up in the rat race, that endless loop of driving to work, toiling away, driving back, all for just a few crumbs. But behold the literal rat race, in which researchers trained rodents to drive tiny cars. Surprisingly, unlike for most of us humans, the driving actually seemed to lower the rats' stress levels, but maybe that's partly because at the end, if they were good drivers, they got Fruit Loops. To find out more, we talked with researcher Kelly Lambert about her rodent-operated vehicles, those would be ROVs, and what implications this might have for humans. So what is this research that you're carrying out here with rodents?
We wanted to teach rats to drive cars, so it's a complex task. So we use some old-fashioned psychological behavioral training techniques and Fruit Loops to shape rats to get into cars and to use the car as a tool to navigate an environment to get to that ultimate reward, which is the Fruit Loop. And so we looked in our most recent study to see if the complexity of their environments, if they had an enriched environment or not, influenced how quickly they could learn. And it did.
Walk us through the experimental setup here.
We had two groups. One group was housed in an enriched environment, kind of a Disneyland of sorts for rats, so they had different stimuli to interact with. And the other group was in just standard laboratory cages, so they had everything they needed, but no Disneyland. And so we were interested in if the enriched environment would facilitate their learning to drive. We'd already shown that we could teach the rats to drive, and we also taught them to steer. So we had forward driving bars and then bars on the left and right so they could steer in different directions, but they were able to do some pretty complex turns.
What made a quote-unquote good rat driver?
To drive 4 times, 4 clean drives, jumping in the car, getting to the Fruit Loop reward, and then coming back and doing that again. So only our enriched environment animals were able to do that. None of our standard house animals, they could get bits and pieces of it, but they were not able to put it together more than one time. So in that particular study, our standard house animals did not get a driver's license.
They have to wait in line again at the DMV to take their test.
Yeah, not fun, even for a Fruit Loop.
What kinds of vehicles do you give to a rodent in the lab?
We could not find one on Amazon, so we had to build our own. So we started with a basic plastic container, and we cut a window out and put the steering bars at the end so that they could just grab the bars. They would complete the circuit, the electrical circuit, although the rats couldn't feel anything. And we added wheels, so that's our rodent-operated vehicle design. Very simple.
Or you actually could tell that they might actually be someone enjoying this process. Can you talk about how you were able to measure that?
So what we did with this last published study, once we taught them to drive, then we took the reward away. It's called extinction trials. And we did that for 4 days. And even the 4th day after they'd been driving and getting nothing, they would still jump right into the car very quickly. That suggested that they had a positive association with that. So that's one way we've gotten at this question of, is this a pleasurable experience or a positive experience? The stress part. So in a very glamorous lab that I have, we like to measure stress hormones in rat poop. We can extract the hormones, and we look at a stress hormone that is similar to cortisol in humans, but it's corticosterone in rats. And then another hormone is DHEA, is the abbreviation, or research suggests that DHEA kind of buffers against the toxicity of chronically high stress hormone levels. And throughout the training for all of the animals in this published group, regardless of whether or not they're in the standard group or the enriched group, the DHEA to core ratio went up in a healthy way. So that suggests that it's healthy. And then in a previous study that hasn't been published, we had a different design where we had half the animals were drivers, like we've done before, and then half the animals, we drove them around the same distance with the same car, but did it via remote control. We called those the Uber rats. They were just passenger rats versus the driver rats. And in that study, only the driver rats had the increased DHEA.
So what comes next with these rats in your lab? Are you going to make rat race cars, SUVs for their friends.
We've thought about a little competition. So we're thinking about neuroplasticity and getting to the brain measures of neuroplasticity. Neuroplasticity refers to the brain's ability to change, to alter environments or lifestyle. So in my lab, we're looking at physical measures. I'd like to look our rats at the end of their lives. They're still alive and driving, and then maybe compare their brains to brains of rats that did not receive the training to see if they have some of those measures of neuroplasticity.
We just have to be careful when we, maybe extrapolate what we're finding here with rodents up to humans. But I was wondering if you could talk about, what this might suggest about how our own brains might work when it comes to stimulation and learning.
We need engagement with our physical worlds and our social worlds, and our brains need experience to develop. So I think it can be generalized or translated to the human brain. Another kind of something I've thought about is, I wonder, since a lot of biomedical research is conducted on rats in those standard boring cages, if that is influencing the validity of the results that we're finding. And I think we need to be looking at more authentic behaviors and complex behaviors. And if we want to learn about our complex emotional disorders or cognitive changes, we probably need to look at more complex research designs. So I think we need to step up our game as scientists and look at something besides a rat and a mouse, and also look at behaviors beyond pressing a bar or turning right or left in a simple maze, because even the rat brain can do so much more than that.
So you saw that there was actually some enjoyment that these rats were getting out of learning this new task. Might that be kind of the same for humans, learning a new language or learning to do cabinetry, whatever floats your boat?
Absolutely. I think that we have individual differences in what we like, that engaging in different tasks, I think more interactive, can be really good for the brain. So learning is an enjoyable experience, and I think it gives us a sense that we're gaining control over our environment, a sense of mastery. And this makes us feel better about our competency in this world. So even though it's kind of a simplistic idea, teaching a rat to drive a car, it seems to be taking us into some complex, even philosophical kind of arenas as we think about what brains can do.
Thank you for taking the time to chat with us.
It's been my pleasure. Thank you for your interest in our driving rats.